Hey y'all, welcome back to eCoreAcademy. I'm Tania, and today I'm back with the part 2 of our parallel and perpendicular lines lesson. So in part 1, I mentioned that part 1 was just going to be a lecture video where we go over the terms and definitions and characteristics and analyze these two types of lines. But in part 2 is where we're going to be putting all that information into practice. Part 2 is also going to be where we're going to be tying up the whole entire linear lines concepts and the entire chapter just together. So I am excited to start today's video. Let's get into today's lesson. All right, so quick review. Parallel lines are just lines that have never intersected or will never intersect and do not intersect on a coordinate plane. They also have the same slope, meaning the m values of both of the lines are equal to one another. Sometimes you don't have the m value, and you will only have a picture of two lines on a coordinate plane. If that is the case, it may look somewhat like this. Pretend there is a coordinate plane in the background with the graphing lines and everything. From what I can see, they're not gonna intersect with one another as they continue because they are straight lines. It seems by the drawing, but you cannot assume, and this concept of not assuming is so essential in geometry. The only way that you will ever be sure is if you have the slopes, first of all, if you know that the slopes of both of these lines are equal to one another, but in this case, we obviously do not have the slopes. The only other way to know that these two lines are parallel to one another is to see if they have that notation, which is kind of like a greater than sign, like I mentioned in the last video. This is the best way to identify if two lines are parallel to one another if there is no slope. If there is no notation or there is no slope, or you don't have the information of the two slopes, don't assume. It's better to not assume. And that concept, like I mentioned, is going to be very, very, very essential in geometry as you will be working a lot with these lines. So, with that being said, let's go on to perpendicular lines. Perpendicular lines do intersect. They are lines that intersect on a coordinate plane at a right angle. They have slopes that are negative opposite reciprocals of one another. So if you take the two slopes of the two lines and multiply them to one another, the product will be negative 1. Sometimes you will see that on a coordinate plane, you will just get these two lines. We know that they're intersecting lines, kind of obvious. But do we know if they're perpendicular lines? Perpendicular lines are different than intersecting lines, as we know that they have to intersect at a right angle. Here, we cannot assume. We don't have any notation telling us that these are perpendicular lines. There's nothing telling us that these lines are intersecting at a right angle. The only time we can say that these are perpendicular lines is if these lines have a notation that tells us that these lines intersect at a right angle, right? That notation kind of just creates a square when connected to both of the lines. So that is another way to look out for it. Remember, it is always great to look at the slopes first to see if these of different lines are perpendicular or parallel. But if you do not have the slope, look out for the notation. If you do not have the notation, nor do you have the slope, do not assume they're not any of these lines. All right, so problem number 1. We're going to go through two problems very similar to one another, but we are going to be tying in all different concepts. So let's get into it. So this question asks us to create a line in standard form that is parallel to the equation 3x plus 5y equals 8 and passes through the point negative 2, 3. The first step is to find the slope of the equation 3x plus 5y equals 8. The way we do that when it comes to standard equations, how we find the slope of standard equations, is just to divide the a value and just divide the b value just to divide the a value by the b value and multiplying it by -1. I might have, sorry, that was me losing my train of thought, but here, listen to this part. It's just going to be m equals -a over b. I was overcomplicating it before. We know that in a standard equation, this is going to be the a value, this is going to be the b value, and this is going to be the c value. It's an ax plus by equals c equation. That's the core of the standard form. So when we're trying to find the slope of this equation, this given equation to us, it's going to be -a, which is 3, over b, which is +5. So that is our slope of this equation. Step 2 is to put the slope and the point, this one, into point slope and solve for standard form for the other line that is parallel to this given equation. The only reason we're going to be using the same exact slope is because we know that parallel lines have the same exact slope. So this slope is going to be, step 2 is just creating the new lines equation, and the new lines equation will have the same slope as the first line's equation. Therefore, we will be using the same exact slope. But you will see later on that that is not the case when it comes to perpendicular lines. And we'll get into that in a bit. But for this case, we know that the slope for the other parallel line is going to be the same as the original equations line, and therefore the m value is going to be -3/5. We know that the point slope form is y minus y1 equals m times x minus x1. There's a whole video on it if you need to kind of refresh on the point slope form. But when we plug it in, we get y minus the y value of the coordinate pair that we're going to be using for our second equation, that because they'll be passing through, 3 equals m, which is -3/5 times x minus -2, which in turn will become x plus 2. Remember, we're putting this in standard form, therefore we have to have the y and the x terms on the left and the c/the constant terms on the right. So we have, the first thing I would do would be just to distribute the -35 to this part over here. So when we do that, it's going to be y minus 3 equals -3/5x minus 6/5. Double checking my math here. I believe it's correct. So going on, let's move the x terms and the y terms to one side and the constants to the other side. Therefore, it will be a y plus 3/5x, because we are adding the -3/5 x to both sides. Subtracting to both sides. No, we're adding to cancel it out. So, sorry, we're adding to cancel it out, and so to both sides. We're done with the left side. We're going to add +3 to both sides to cancel it out on the left and make it go to the right. So it's going to be -6/5 plus 3. One way to do all of this is obviously to make this constant go a little bit, like you can just add and subtract, which is the easy way out. But something else I can also look for in the future, if it's not as easy as this, would just be multiplying by the common denominator of both of the sides, which is going to be 5/1. Just so we can cancel out the denominators and make everything a whole number. Please, hopefully you can see that this is a 5/1. We're going to be multiplying that to both sides. So we're going to distribute this 5 to this y plus this 3/5x. And this 5, we're going to be doing the same to -6/5, distributing it to that, plus the 3 over here. When that happens, we're going to get 5y plus, it cancels out here and here and here, so it's just going to be 3x equals, it's going to cancel out over here and here. So it's going to be negative 6 plus 15, which we know is 9 over here for the right side. And that is our actual final thing. But remember that it's going to be ax plus bx, ax plus by equals c. So therefore the x term will go before the y term. And so the final equation will be 3x plus 5y equals 9. And that is our standard equation, our linear equation in standard form that is parallel to the equation 3x plus 5y equals 8 and passes through the point negative 2, comma 3. Remember, we know that the slope of this equation is negative 3/5, and since we plugged into this one, we know the slope of this equation is also negative 3/5. The slopes are the same, they're parallel lines. Simple as that. As you can see, there is quite a bit of work involved, but nothing too difficult. Problem number 2. Similar question, similar problem. We are asked to create a line in slope-intercept form that is perpendicular to 2x minus 3y equals 11 and passes to the point 4, comma 5. So the only difference is that we're going to be, number 1, finding a line that is perpendicular to the given equation, and also we're going to be we're going to be presenting the other line in slope-intercept form instead of standard form. So step 1 is what we're going to do is find the m value, the slope of the given equation, just so that we know what we're working with. Remember, to find the slope of a standard form equation is just to take negative a, which is in this case 2, over b, which in this case is going to be negative 3. Remember, the negative is attached to that. And therefore, the m value of this equation is going to be 2/3. In step 2, we're going to be finding the actual perpendicular line that passes through the point 4, 5. But remember, it's a perpendicular line. It's going to be perpendicular to this equation. We know that the m value, the slope for this equation, is 2/3, but we also know that perpendicular lines have opposite negative reciprocals. And the best way to know that is, number 1, the m that we are going to be using here is not going to be this m, because then it'll be parallel lines. So we have to find the negative opposite reciprocals. So the m for step 2, which we'll call m2, will be opposite, which is 3 over 2, and negative reciprocals. And it's as simple as that. We can double check when multiplied to one another, the two different m values, it will equal -1, and they will cancel out. So that was great. That is going to be the m value that we will be using in step 2. So we're going to put this new m value, -3 over 2, and the 0.45, which the new equation will be passing through, into point slope form to find our new equation. So we know that y minus 5 equals -3/2 times x minus 4 is what our point slope form will result in. All right, so now the next thing we have to do is distribute. I think that is the best way to do that's the next step for anything really. So it's going to be y minus 5 equals -3 over 2. And then it's going to be plus because there are two negative signs. And then it's going to be 1, 2, like we're just going to cancel it out here. 1, 2, and it's just going to be 6. I'm double checking my work as I go, so I'm just cross-referencing here. All right, so this is a new equation that we're dealing with. Remember that we are putting this equation into slope-intercept form. Therefore, it's going to be y equals all the other terms. So we already have a singular y here, and there are no other y's to add or subtract to it. So the best thing to do here is just to add 5 to both sides, cancel the 5 out on the left side, and put it to the right side. And if we do that, we will get y equals -3 over 2 plus 6 plus 5, which in turn we will continue to further simplify. And since my mistake, there is no x, I forgot to place the x. Hopefully you didn't make that mistake. But which in turn, there are no more x terms to add or subtract to -3/2 x. Therefore, that's left alone. So we just have to add these two constants up, and we'll have our slope-intercept form of the line, the new line that we've created, which is perpendicular to the original equation that was given to us and passes through the coordinate pair of 4, 5. All we got to do is add the two constants for the finishing, or for the final touch. So excuse my handwriting, but plus 11, as 6 plus 5 equals 11. And just to double check, that is the correct answer. So our final answer to this question is going to be this equation right here. Y equals -3/2 x plus 11 is the line in slope-intercept form that is perpendicular to the equation 2x minus 3y equals 11 and passes through the point 4, 5. Another way to double check this is we know that the m value for this equation over here was 2/3, correct? And when the new equation was put into slope-intercept form, we already know that the slope-intercept form is y equals mx plus b. We already know where the m is, and in this case, it's the -3 over 2. When multiplied to 2/3, it's going to be equal to -1, which continues to serve and correctly serve to the definition of the perpendicular lines. I did overcomplicate that at the end, but simply when the two slopes of the original equation and the new equation are multiplied to one another, the answer is going to be -1. All right, I hope that made sense. Again, I'm leaving this here for one more second. Pause if you guys need to copy anything down, or kind of understand the steps. The steps are written down here. So now that we're done with that, we are done with the lesson. There were just 2 problems, but they were quite thorough problems. I hope you guys enjoyed this video. I'm sure you guys may have questions, and if you do, please do not hesitate to leave them down in the comment section below. For more practice, do visit our website. There will be more practice that will benefit you guys, as I'm sure that you guys probably do want more practice than just 2 problems. So with that being said, here's our website link. If you guys need to contact us for anything, our email is right here, and we have our social platforms listed here as well. Follow us there, subscribe to our channel, comment on this video with any questions, comments, and concerns, and also like this video. And I hope you guys enjoyed this video. Please do let us know if there's anything that you guys have any questions on in the comment section down below, and we'll get back to you ASAP. But until then, see you guys in my next video. Have a great day or night, where you guys are. Bye.